All righty. Well, hi, everyone. Welcome to tonight's presentation on energy efficiency and LES's sustainable energy program. My name is Caitlin, and I am an AmeriCorps member serving with Conservation Nebraska's Common Ground program. Conservation Nebraska's mission is to protect our state's natural legacy by educating the public, supporting communities, and increasing civic engagement, which we accomplish through locally led education efforts and community engagement projects to address local conservation concerns. Before tonight's speaker, there's a few housekeeping things to go over. Your cameras will remain off and you'll be muted throughout the presentation. So if you have any questions, please put them in the chat or the Q&A section, and we'll answer those at some point during and after the presentation. This presentation will be recorded and will be uploaded to Conservation Nebraska's YouTube page within the next couple of weeks. So if you miss any part of today's presentation or would like to revisit it or share it with somebody else, you can do that. You can find it there. And then following the presentation, we will have a very brief survey that should take less than a minute to complete, and it just helps support programs like this. So we really, really appreciate you taking the time to fill those out. And if anyone in attendance is interested in speaking with a Conservation Nebraska member regarding conservation issues in Nebraska or to find out more about what we do, I'll put our email in the chat. And so for tonight's presentation, we have Jay Stoa, who's an energy service specialist with LES, and he's going to talk to us today about energy efficiency and LES's sustainable energy program. So I will let him take it away.
All right, so my name's Jay Stoa, like she said, and what we're going to be, now it's not working. There we go. All right, my agenda, what I'm going to talk about, energy efficiency. I'm going to give you some tips and suggestions that will be outside of our sustainable energy program. And then, of course, we're going to be talking about our sustainable energy program for our residential customers. And don't hesitate to ask questions as I'm going along here. We had a technology issue here, so I don't have all my notes. So hopefully I can, like we say, wing it. So to start off, what is energy efficiency? If you use AI, this is what I got. Using less energy to perform the same task or produce the same outcome. In other words, it's about reducing energy waste while maintaining or improving performances. And obviously, our sustainable energy program is going to improve some of those energy efficiencies, and you're going to get an incentive with that. So, what I want to be able to do is just do a quick rundown of things that I look for if and when I'm evaluating people's energy consumption. So if you think about your home, you're going to have all of your plug loads. You're going to have like your TVs, cable boxes, electronics, routers, your microwaves, even in your task lighting. And then your appliances, refrigerators, freezers, clothes dryers, dishwashers, really everything that is using energy, your electric meter is going to be seeing it. And then, of course, you're going to have what I call your seasonal loads. And depending on if you heat with electric or obviously air conditioning, you're going to see that in your electric bill. And then one thing I'm going to point out during this next slide is what we call seasonal plug loads. And if you are a Lincoln Electric System customer, every time you get a bill, you're going to have this graph. Like, once again, when I evaluate people's energy use, I'm pulling up this graph. This graph really tells me a lot. And if you can see, it's 2 years of energy consumption, and the graph is based off of average kilowatt hours per day. So that's basically how much energy you're using per day for each month in that 2 year span. So once again, so what I'm looking at, what I want to look for is what I call base loading. So that's going to be all your appliances, your lighting, and your plug loads. So in this graph, to me, when the month that shows the lowest energy use is going to be the months of April and May. So that's what I'm going to call the base loading for this particular customer. And then once again, so we have the seasonal. So this customer has gas heat. So we're seeing that big increase during the summer months. And that's what I'm calling the seasonal increase during the summer months because it's going to be air conditioning. One thing that I do want to point out, this customer does work from home a couple of days out of the week. And instead of turning up their whole house thermostat to keep that space they're in warm, she will utilize a space heater. And that's the perfect way I think you should use space heaters. If you're just going to be occupying a room rather than heating your whole home, by raising the temperature, just lower the thermostat setting and utilize that space heater. And obviously, you want to shut it off when you're not in that space. These are just real quick things that people can do or should be starting to do. When we're talking about all of your interior lighting, you want to look at replacing your incandescent with LEDs. And you really want to start with the most used light fixtures. Obviously, LEDs are going to use 75 to 90% less energy than the incandescent. Utilize motion sensors. Um, Getting ready for this presentation, one area that I thought of where I don't have a motion sensor and it would make the most sense is in our utility room where our washer and dryer is. So actually, that is something I'm going to be doing to utilize a motion sensor. And then I do have one in my garage, which is great because sometimes if you go out there, turn the light on, then you forget about it. And then, it's 12 hours later that the lights are on. Earlier this month, my granddaughter had a birthday and it was down in my daughter's and son-in-law's basement. And I noticed that they have 10 75-watt recessed light fixtures. And, talking to them, they're telling me they do utilize the basement a lot and it's about on 2 hours a day. So if you add up all of that energy, it's going to consume 550 kilowatt hours per year. And Caitlin, can you help me? The pictures, what's the dollar amount? I apologize.
It says 35.
I don't have my notes with me. So basically, those light fixtures are going to cost, $35 a year just to light the basement. So replacing with LED, you can utilize an 11 watt LED bulb. And that's going to drop down the energy to 88 kilowatt hours per year. And then I don't see the dollar amount.
And that one's $6.
Sorry, $6. Thank you. And I apologize. I'm not able to see my notes when I'm, and then so basically what we're looking at, if you were to replace those 10 fixtures, you're going to save about $29 per year. On exterior lighting, once again, replacing with incandescents with LEDs, utilize photo eyes or motion sensors. On our deck, we have decorative lighting, but I am using a dusk sensor. So once the sun goes down, the lights will turn on and they will shut off after 5 hours. If you drive around town, sometimes you see all these lights on that are these decorative lights that are on almost 24 hours a day. So use the technology if it's there to save energy. Any questions on that?
Don't see any popping up so far.
So on your plug loads, there's one thing that you can utilize, which I think is a great tool. You can plug in any of your plug-in devices to monitor how much energy it's using. So this is at my home. I have an older 20 cubic foot freezer, and really it's about almost 30 years old, and I'm having to defrost it about 4 times a year. So what I want to show here is when the compressor's running, if you can see the image on the screen, the compressor's using about 183 watts. For the purpose of getting this presentation in, I only monitored it for about 9 days or 217 hours. But in that 9 days, it used 20.7 kilowatt hours. So with that, I'm able to I'm able to estimate how much energy it is using per month. So the freezer itself is going to use about 70 kilowatt hours per month. Per year, we're looking at about 840 kilowatt hours. And then if you multiply that by our energy rate of 6.3 cents, it's costing me about $53 a year. One thing that I do want to note, the 6.3 cents, we do have a winter rate and a summer rate. So that's a combination of what the average rate is for the whole year. So what do we look for when I'm replacing any appliance or freezer, refrigerator? Most likely, you're going to have an energy guide when you go to these stores to purchase new equipment. So this particular freezer that I would look at to replace mine is going to use 438 kilowatt hours per year. And you want to look for the Energy Star label. Basically, that is telling us that it is the most energy efficient freezer out there. And if you look at it tells you what the lowest kilowatt hour is to the highest kilowatt hours. And obviously, the Energy Star is going to be the most energy efficient. So, with the data that I got from the watt meter, I can estimate what I'm going to save per year. So basically, replacing my old freezer with a newer one, I'm going to save about $25 per year. And excuse me. So so $25 per year, and hopefully I won't have to keep doing a defrost on a quarterly basis. So it seemed. Okay, now I'm going to get into the sustainable energy program. Was there any questions about the information that I just went over?
We do have one question that just popped up, and they said that they use their dishwasher, washer, and dryer in off-peak hours during the day on weekdays. Does that help save electricity?
Um, so if we had time of day rates or time of day rates or energy use, using it on an off-peak day or time, the energy cost is going to be no different than when you would normally do use those. Um, in the heat of the summer, it would probably be best not to use those devices that are using and creating a lot of heat, especially during the day, because your air conditioner has to remove that heat. That would probably be my only recommendation if and when you use those heat appliances like an oven and stuff too during the peak of a summer hot, really hot day. All right. So our sustainable energy program, I'm going to see if I can minimize. There we go. Move it. Okay. Sorry for the technical issues here. So basically, LES, our program provides a financial incentive for customers to make energy efficiency improvements. And our program is geared for you to make that step. If you're purchasing like the new air conditioner, what we're going to be talking about, there's going to be a standard unit, there's going to be a higher efficient unit. And our incentive is going to be for that higher efficient unit. And basically, investing in the energy efficiency helps LAS reduce our peak demand, but it's going to help you, the customer, to be more energy efficient and reduce your operating costs. So this year's program, every year it's a budgeted year program. This year we started out about $2.2 million. As of yesterday, we've had about $350,000 of incentives come through the program, and it isn't just residential. This presentation, I'm just focusing on our residential program. We do have commercial and industrial incentives also. And that's where part of that money is coming from that we've paid out on an incentive. All the incentives are first come, first served basis until the funds are depleted. I will say it's been a while since we depleted all of our funds and we had to finish before the end of the year. If and when it does to get real low, we're going to get that messaging out, whether it be in the news, newspaper, or flyers, or we send emails to customers too. So each program that I'm going to be talking about, we have a list of what we call participating contractors. And how our program works, the contractors that are going to do the work for you, whether it be an air conditioner, heat pump, insulation, or the heat pump water heater, they will actually give you the LES credit as a deduction off their total cost. And then we will reimburse the contractor after we get confirmation that you were credited. And obviously, that whatever's been done, it meets our energy requirements for the incentive. And I'm not going to go in the greatest detail about everything about each program. So obviously, you can go to our website, find a list of the contractors and more information about each program. The first thing that I wanted to talk about in our program is our whole house ceiling and insulation, and this is going to be for older homes, kind of two-tiered in the age of the homes. If your home was built, in the mid to late 70s, there's a chance you may have minimal attic insulation. If you have a home that was built prior to the 1960s, there's a chance that the exterior walls are not insulated. So the program requirements, what I was talking about, wall insulation, for LES to have a contractor to put insulation into your exterior wall cavity, there has to be no insulation in the wall cavity. Attic insulation has to be less than 6 inches, or what we call an R19. When we talk about insulation, it has an R value. Basically, that's a value that restricts flow with the insulation. So the higher the number, the more energy efficient the insulation is. We do require that the home have a pre and post blower door test. And basically, this is a measure of how leaky your home is and then how much it is improved after you get insulation levels up to snuff. So on the exterior wall insulation, the contractor is going to get that wall cavity up to at least an R13. And then our incentive is 80 cents per square foot of frame wall area. And then for adding attic insulation, it's going to bring up the R value to an R49. And then our incentive is 50 cents per square foot of attic space. And I will say it's just conditioned space. It is not if you have a garage, and if you're going to add insulation to the garage, that would not qualify. Was there a question?
Let's see. It looks, somebody was just saying that they've used the LES energy program before and they loved it.
Oh, thank you. Well, I'm sorry. I just didn't know if it was a question about what I went over. So with both of these criteria, so if you have that older home, the walls are not insulated and you have minimal attic insulation, you can just choose to one or the other or do both. So you do have an option. In previous years, if you had that type of home, we made you do both to qualify for our program. Here you can just possibly do the attic insulation if you want. We do have a cap that the total incentive cannot exceed $1,500, and then or 50% of the total cost of the project. All right. So when we talk about sealing the home up, if you just think of your home as a whole, the whole, what I'm going to call the thermal envelope, anything that is exposed to the exterior, there's an opportunity for air leakage. And this image is basically just showing you how the air can penetrate and then exit out through the top of the attic. One thing that I do like to point out is that the attic, if there's a lot of leakage in the attic, you're going to get a lot more flow coming through the lower penetrations more freely. So if you can seal up your attic the best that you can, you're going to reduce the potential of air coming below or at the lower levels of the home. And our program is going to, um, I'll just get to the next screen here. So this image here is a blower door. The contractors will have this device, and basically what it's going to do, it's going to depressurize your home, and it's going to give us a known measurement that we can determine how leaky your home is. But also, what it's going to be able to do is you're going to be able to walk throughout the home and identify the areas where we're bringing in that cold or hot air, whatever it may be, and that's hopefully will be the areas where they can focus on sealing up your home. And then basically the post blower door test is just going to be able to show us how much that has improved after insulating and sealing up the home. And these are the measurements that the contractors will give us so we can document it and quantify how much the improvement was on sealing up your home. So if your home was built prior to 1960s, this is a test that you can do to see if you can determine if the exterior wall cavity has no insulation. So I call it the outlet inspection method. When I go to homes, this is what I do to see if the walls are insulated or not. So obviously you want to turn off power to the outlet at the breaker, remove the outlet cover, and then just use a wooden dowel, or what we're saying here is maybe even a plastic zip tie. And then you just want to feel around the outlet box in the wall cutout. And what you're doing is if you feel any resistance, that's probably telling you that there's insulation there. And then if you can move around and not feel anything, most likely the walls are not insulated. But obviously, the insulation contractor will confirm that for you too. All right. Attic inspection. If you can see your roof rafters, most likely the depth will be less than that 6 inches, or what we call that R19 value. And so adding insulation to the attic would qualify for our program. And then after they add the insulation, and when they're sealing the attic penetrations, if you think of any of your light fixtures, recessed lights are notoriously real leaky. They will address that, tightening up those fixtures before they add the insulation. Okay, so what I'm trying to do here is kind of show you how, if you do have an older home with no wall insulation, minimal attic insulation, and if it's a drafty home, what I'm trying to show here is how the program can affect the heating performance of your home. So in the blue area here, this is the home, the walls that are not insulated. It's a leaky home. and then there's minimal attic insulation. Adding the insulation, reducing some of the air infiltration, and reducing some of the heat loss through the insulation in the attic. This is just a value. Um, when you're heating your home, this is basically how much energy that you have reduced that you needed by participating in the program. And then same for the cooling. When we talk about heating and cooling your home, when a furnace is sized for a home, it needs to be able to um, overcome basically a 75 temperature degree difference from inside to outside. And then during the cooling, it's only a 20 degree difference. So that's why if you're looking at, the values of the heating or the cooling that is needed, the cooling, you don't need as much energy to cool the home. Benefits of sealing and insulating your home. Just by insulating your home, reducing some of that air infiltration, um, estimated you can save 42% on your heating cost, 36% on your cooling cost. And so this particular home, since they did both the walls and the attic, it's going to qualify for the max of $1,500. And obviously it's going to improve the comfort level of the home. So now this is a different scenario. The walls are insulated. There's minimal attic insulation, and it's a semi-drafty home. So once again, if you on the left part of the graph here, that's telling us what the attic uh, heating BTUs is, and then how much infiltration, and then you can see how much it dropped by improving some of the air infiltration and then adding the attic insulation. Same concept with the cooling. You'll note that the attic insulation, adding that additional attic insulation doesn't make a huge impact, but improving the tightness of the home definitely will. Because if you think about the summer months, not only are you bringing in hotter air, but you're also bringing in moisture that the air conditioner has to remove. So that's why there's a greater impact by tightening up the home. So just by adding the attic insulation and sealing it up, we're going to save about 18% on heating, 15% on cooling, and then 1,500 square foot attic space is going to qualify for $750 LES incentive. And obviously, we're going to improve some of that comfort level. Any questions about whole house sealing and insulation?
Yeah, we got one question here. They said, "What do you do with older homes that have knob and tube wiring in the attic?" I have heard some
Uh,
people say that it's a fire hazard to put insulation up in the attic
yeah,
around knob and tube.
that is a true statement. Ideally, you want to upgrade that wiring up there. I actually think the city will not allow you to add insulation in the attic if it's going to impede that knob and tube wiring, unfortunately. But if it's a leaky attic, that's stuff you can do without adding the insulation, though, too. So now we're going to move on to our air conditioner and heat pump incentives. So basically, SEP qualifying air conditioner and heat pump is going to be 13% more energy efficient than standard air conditioner. Let's say you have a 20-year-old air conditioner. By installing a qualifying system, it's going to be 38% more energy efficient. Air conditioner, the incentive is only going to be $300, but a heat pump is going to qualify for $1,000 incentive. I'm going to go back to the graph that I showed earlier because I want to kind of show you or reference how you can estimate what the savings will be by replacing your air conditioner. So once again, we have our base load. And if you remember, I said there's about 5 months where the air conditioner was used in this home. So what you want to do is you want to accumulate the total energy used in those 5 months. So this particular home, they use 4,028 kilowatt hours. And so what I'm doing is I'm subtracting the base load for that 5 months. And by subtracting that, I can determine how much energy the air conditioning used just to cool that home during the summer months. So you can see 2,780 kilowatt hours. So it costs this homeowner about $217 to cool their home. Um, when we talk about energy efficiencies for air conditioners, they're rated in SEER 2. So SEER, the SEER, that's seasonal energy efficiency ratio. And so the higher the number, the more energy efficient the system is. So 20-year-old air conditioner, I estimated at 11 SEER 2. And for a qualifying air conditioner, we ask for two energy ratings, and it's a 12 EER and then a 15.2 SEER 2 rating. And the one thing about the EER rating, that's how the unit is going to perform at the hottest day of the year. So basically, when it's at 95 degrees, it's not going to be as energy efficient as the seasonal rating, but that year two is telling us how it's performing on the hottest day of the year. So basically, once again, we're improving cooling efficiency by 38% or 1,056 kilowatt hours per year, or replacing the air conditioner is going to save about $83 per year. And that does qualify for a $300 LES incentive. All right. I'm not sure if everybody's familiar how a heat pump works. So during the summer months, it's gonna the heat pump, air source heat pump is gonna exactly like what an air conditioner does. And then how it's doing that during the refrigeration cycle, it's transferring the heat from the indoors to the outdoors. If you ever walk by an air conditioner on a hot day, and if you put your hand above where the air is blowing out, it's going to be hotter than what the surrounding air is. So it's removing the heat from the home to cool your home, if that makes any sense. Now, during the winter months, the refrigerant cycle is reversed. So basically, it's transferring the heat from the outdoors to the indoors. One thing a heat pump will need is going to need supplemental heat to assist the heat pump because the colder it gets, you just don't have as much heating capacity. So you do need supplemental heat, and that can be an electric furnace or a gas furnace. Um, so what I want to try to show here is the home that we insulated earlier during the presentation here. Um, every home, when the heating and cooling system is sized, it's going to be based off of the heat loss and heat gain. So the home that we insulated earlier through the whole house sealing and insulation program, the heat loss, this is all of the operational costs are based off of these loads. So if you have an existing furnace with existing system, an electric furnace with just an air conditioner, I've broken out the heating and cooling costs. So you can see that if it's just an electric furnace, it's almost going to use 11,000 kilowatt hours, or it's going to cost the homeowner $616 to heat. And then a standard air conditioner is going to be right about $105. Installing an SEP qualifying heat pump the energy use is going to drop down by well over half. So the heating cost drops down to 285, and then the cooling cost down to $93. So it's going to save about $343 per year. And then this will qualify for $1,000 LES incentive. Now, I had mentioned earlier, you can install heat pump with a natural gas furnace. So this scenario, a gas furnace is going to use about 469 therms, costing about $352 to heat the home. If you add a heat pump, we're going to offset some of that heating therms and then add some kilowatt hours for the heat pump to operate. So the heating cost drops down to 294 and cooling is at 93. Excuse me. And then you're not going to see as big of energy savings with a gas furnace and heat pump. So it's only going to be about $70 per year, but it still does qualify for that $1,000 LES incentive. Then we do have an incentive for geothermal heat pumps. Um, so basically, if you think about the air source heat pump, it's transferring heat of the surrounding air. Geothermals are going to be a lot more energy efficient because it's using the ground source where it's going to be more of a constant temperature. Same scenario. We have an electric furnace with an air conditioner. Now you can see what a geothermal can do in seasonal heating and cooling cost. You're going to have a greater energy savings, and then almost $500 per year in savings. And the incentive for a geothermal is going to be a lot higher than just the air source heat pump. All right, now the final one. My voice is starting to go out, so I do apologize. Heat pump water heater. So I don't know if you guys can see my mouse here, but an electric water heater is going to kind of resemble the tank here, but the heat pump water heater is going to have a heat pump on top of it. So how the heat pump works, it's going to pull heat from the surrounding air, and then the compressor and the refrigerant is going to absorb that heat, and then the hot refrigerant heat is going to heat the water. One thing that I do want to point out on a heat pump water heater, it needs to be in a room that we can have anywhere between 700 and 1,000 cubic feet of free air volume. So basically, if you have a 10 by 10 room with 7-foot ceiling, you're going to have 700 cubic feet of air to be able to move for the heat pump to operate properly. And then a 10 by 12-foot room with an 8-foot ceiling is going to give you that a little over 1,000 cubic feet of air volume. All right. So ideally, heat pump water heater is going to replace an electric water heater. So we have an image of an electric water here. And if you look at the two openings on the water heater, the heating elements are there. And those are going to be about 4,500 watts when we're heating the water. And then here's an image of a heat pump water heater. And this particular heat pump water heater, it's in a really older home, but it's in a really big, huge open space. So the air volume exchange works really great with that type of application. All right. So if you have a family of four, and if you have an electric water heater, you're going to use approximately 4,000 kilowatt hours per year to heat the water. And it's going to cost about $250 to heat the water with an electric water heater. Heat pump water heater is going to reduce that down by at least half. So, dropping it down to $127 to heat the water. So you're looking at right at $127. And that does qualify for a $500 LES incentive. And that is it. Like I said, I apologize. Didn't have some of the technology with some of my notes, but hopefully I got the point across. But if you do have any questions, let me know.
We do have a few questions. I'm also going to really quick share that poll so people have some time to fill those out. So for questions, first one is, if I want to install a heat pump for heat and AC, can I keep my 20-year-old gas furnace for the supplemental heat in the winter?
Yes, but so when it comes to energy ratings of heat pumps, usually to get the energy ratings that we need, it's unfortunately going to be a combination of the outdoor unit, the indoor coil, and sometimes the furnace. Um, it helps the energy ratings. And the reason I say that is older furnaces just have like a standard blower, which is distributing the air throughout the home. The newer furnaces have what we call an ECM motor or variable speed, which improves the efficiencies. You can install a heat pump with an older existing furnace, but it may not qualify for the LES incentive.
All right, and then next question, can you use geothermal in an existing residential neighborhood?
You can. So geothermal, uh, you, you, you would have to drill the wells, and that's where the biggest the expense is going to be drilling the wells, because you can use your existing ductwork, the air handler that they're going to put in, but there would have to be wells drilled. And in town, those most likely would have to be a vertical loop, and they'll go down 150, 200 feet. And that's where you're going to see the greatest expense. And that's where, you just have a contractor get those options. And what you'll want to do is kind of do what we did on the air conditioning, figure out how much you're spending to cool and heat your home. Do the same thing if you have a gas furnace, figure out how much are you spending to heat and cool. And then the heat pump, geothermal, they should be able to tell you, how much, it's going to cost to heat and cool with that geothermal. Or give me a call and I can, go over, analyze your gas and electric, whatever it may be, and just do a quick cost analysis for you.
Perfect. Let's see. Do you know if geothermal also introduces additional radon into the home?
That is a great question. I don't know that I would have that answer for you. So the well field is going to be out, out in the yard, the vertical loop, and then they'll have a horizontal pipe that would be it. To me, it would be no different than maybe your water lines, because they got to come from the outside in. That's a great question. I don't know that I would have that answer.
All right, and looks like we've got one more. Do these incentives also apply to rental properties, or do you have to own?
No, yeah. If you own a rental property, um, everything that we just talked about, you would be able to do to get the LES incentive. Um, yeah, as long as you're paying for it, the contractor is going to give you the credit. It can be for rentals, yes, without a doubt.
And then we did have one more come in. Would a church qualify for insulation incentives?
It, so I'm going to say yes. And that would be something that you would just call me and we could talk through that. Um, an issue if it's a bigger church doing the blower door. And these are, one-offs where I we would have the discussion on, how you could qualify, and then, I would probably personally come out, take a look, and give you option as to how we could incorporate the LES incentive.
Looks like that's the last question that's popped up so far.
And like I said, I do have my email there, and that phone number is my office phone. So don't hesitate to reach out if you have any other questions.
Perfect. Yeah, if there's no other questions, I think we can probably end it there. So I'll end the poll. And perfect. Yeah, thank you so much for
All
presenting
right,
for us
Caitlin.
today.
All right. Thank you.
And everyone, I hope you all have a great rest of your day.
You too.